Imagine walking outside just after sunset. The sun has disappeared below the horizon. The sky slowly darkens. Stars begin to appear, just like every other night. Then, a strange orange glow appears in the east. At first, you think it's an unusually bright planet, but every minute, it becomes brighter, larger, hotter. Within an hour, the entire night sky is glowing. People across the world stop and stare. Astronomers freeze in disbelief, because the impossible has just happened. Jupiter, the largest planet in our solar system, has suddenly become a star. Not another planet, not another moon, a real, burning, nuclear-powered star. For billions of years, Jupiter has been a giant ball of hydrogen and helium. It contains more mass than every other planet in the solar system combined. Yet despite its enormous size, it has always been just a little too small. Scientists estimate that Jupiter would need around 80 times more mass to ignite sustained nuclear fusion and become a true star. But, what if somehow, against all laws of probability, that missing mass suddenly appeared? Within seconds, the crushing pressure deep inside Jupiter's core would rise to unimaginable levels. Temperatures would soar to millions of degrees. Hydrogen atoms, normally pushing each other apart, would suddenly begin fusing together. For the first time in history, Jupiter would produce its own light, its own heat, its own energy. A second sun would be born. The transformation would be almost impossible to ignore. Millions of kilometers away, Earth's telescopes would immediately detect an enormous increase in brightness. Within minutes, news alerts would interrupt television broadcasts. Every observatory on Earth would point toward Jupiter. Scientists would initially think their instruments had failed, but they hadn't. Jupiter would continue growing brighter, minute by minute, hour by hour. Eventually, it would become brighter than Venus, brighter than the full moon, and finally, bright enough to cast shadows across Earth during the middle of the night. For the very first time, humanity would experience something no civilization has ever witnessed. Two stars in one solar system. People would flood the streets. Millions would record the sky. Social media would explode. Some would celebrate, others would panic. Religious leaders would call it a sign. Governments would demand answers. Astronomers would work without sleep, trying to understand the greatest discovery in human history. But while everyone is looking up, something far more important is beginning to happen. The solar system itself is starting to change, because stars don't simply shine. Their gravity, their radiation, and their energy shape everything around them. The birth of a second star wouldn't just change the night sky. It would begin rewriting the future of every planet orbiting our sun, including Earth. And within just a few days, humanity would discover that the beautiful orange light filling the night sky is only the beginning of a much bigger disaster. The excitement doesn't last long. At first, the world celebrates. News channels call it the greatest astronomical discovery in history. Scientists name it the birth of Earth's second sun. Millions stay awake through the night, watching Jupiter blaze brighter than anyone ever imagined. The sky is no longer truly dark. Even at midnight, a soft orange light stretches across the horizon. Shadows appear where there should be none. Animals become confused almost immediately. Birds begin singing in the middle of the night. Owls abandon their nests. Sea turtles hatch on beaches, but crawl toward Jupiter instead of the moon. Around the world, nature starts losing its sense of time. Humans notice something strange too. People struggle to sleep. Our bodies evolved around one bright day and one dark night. That rhythm controls nearly everything inside us. Hormones, body temperature, sleep cycles, even our immune systems. Now, the nights never become completely dark. Insomnia spreads across the globe. Hospitals report increasing cases of anxiety, depression, and extreme fatigue. But these are only the smallest problems. Because Jupiter isn't simply producing light, it's producing gravity, solar wind, and enormous amounts of radiation. The solar system has existed in delicate balance for over 4.5 billion years. Every planet follows a predictable path around the sun. Every orbit depends on gravity remaining stable. Now, a second star has entered the equation. Astronomers begin running computer simulations. At first, the results seem impossible. Some models predict almost no immediate danger. Others predict complete chaos. No one knows which outcome is correct. But everyone agrees on one terrifying fact. The solar system will never be the same again. Jupiter's moons are the first to experience the change. Europa, Ganymede, Io, Callisto. For billions of years, they reflected sunlight. Now, they're illuminated from both directions. Frozen worlds begin warming. Ancient ice starts melting. Huge plumes erupt into space. Some scientists become excited. Could hidden oceans now support even more life? But that excitement quickly fades. Because Jupiter's increasing energy also strengthens its magnetic environment. Radiation around the giant planet reaches unimaginable levels. Any spacecraft nearby would be destroyed within hours. Meanwhile, Earth receives something unexpected, a little more heat. At first, the difference seems tiny, barely measurable. Average global temperatures increase by only a fraction of a degree. Most people don't even notice. But Earth's climate is incredibly sensitive. A change that small, repeated every single day, every month, every year, begins reshaping weather patterns. Winters become shorter, summers grow hotter, heat waves arrive earlier than ever before. Polar ice starts melting faster. Ocean temperatures slowly climb. Storms become stronger. Hurricanes draw more energy from warmer seas. Drought spreads across regions that once depended on regular rainfall. Farmers begin reporting lower harvests. Scientists warn governments. This is only the beginning. Because Jupiter is still changing. Fusion inside its core continues growing stronger. Its brightness increases month after month. And every increase means more energy flowing across the solar system. Then, astronomers make another terrifying discovery. Jupiter's new stellar wind, a constant stream of charged particles, is beginning to collide with the Sun's own solar wind. For the first time in history, two stars are interacting inside the same planetary system. No one has ever witnessed anything like it. The boundary between their powerful magnetic fields becomes unstable. Gigantic waves of charged particles ripple through space. Satellites begin malfunctioning. Communication systems experience strange interruptions. Auroras appear far closer to Earth's equator than ever before. People in tropical countries look into the night sky and see brilliant curtains of green, purple, and red light dancing overhead. Beautiful, but deeply unsettling. Humanity starts asking a frightening question. If Jupiter keeps getting brighter, how much longer before Earth can no longer survive? And the answer may come much sooner than anyone expects. Months pass. Jupiter continues shining. It has become a permanent fixture in Earth's sky. Children born after its transformation can't imagine a universe with only one sun. To them, two stars have always existed. But for everyone else, the beauty has faded. Now, the consequences are impossible to ignore. Average global temperatures continue rising. Not by dozens of degrees overnight, but slowly, relentlessly, year after year. The extra energy from Jupiter doesn't replace the sun. It adds to it. At first, scientists believed Earth might adapt. Instead, the planet reaches a dangerous tipping point. The Arctic begins disappearing. Every summer, less ice returns. The brilliant white surface that once reflected sunlight back into space is replaced by dark ocean water. And dark water absorbs heat. More heat creates more melting. More melting creates even more heat. The cycle feeds itself. Soon, Greenland starts losing ice at an unprecedented rate. Antarctica follows. Sea levels begin climbing, not centimeters, meters. Coastal cities build taller seawalls. Then even those become useless. Entire neighborhoods disappear beneath rising oceans. Ports close. Airports flood. Millions abandon their homes. The first climate refugees begin moving inland. Within a decade, their numbers reach hundreds of millions. Fresh water becomes another crisis. Mountain glaciers, which supply drinking water for nearly 2 billion people, shrink rapidly. Rivers that once flowed year-round begin drying up. Reservoirs empty. Countries compete for every remaining source of clean water. Meanwhile, the atmosphere becomes more violent than ever before. Warmer oceans feed enormous hurricanes. Storms grow larger, stronger, longer lasting. Some survive for weeks instead of days. Tornado seasons become unpredictable. Lightning strikes increase dramatically. Entire forests ignite during record-breaking heat waves. Wildfires merge into giant firestorms stretching hundreds of kilometers. Smoke darkens the skies of entire continents. Breathing clean air becomes difficult. Agriculture enters a state of emergency. The growing seasons no longer follow familiar patterns. Rain falls in the wrong places. Drought devastates fertile farmland. Fields that once fed millions become cracked wastelands. Global food production begins collapsing. Wheat, rice, corn, every major crop becomes harder to grow. Food prices soar. Governments ration supplies. International trade weakens under growing political tension. Then, the oceans begin changing. Warmer water expands. Sea levels rise even faster. Coral reefs, already under enormous stress, disappear almost completely. Countless marine species lose their habitats. Fish populations collapse. Entire fishing industries vanish. For billions of people, a major source of food is gone forever. Even the air feels different. Longer summers, shorter winters, more humidity, more extreme weather. Scientists call it a runaway climate shift. A planet gradually leaving the conditions that allowed human civilization to exist. Then, astronomers make another discovery. Jupiter isn't behaving like a stable star. Its brightness fluctuates, sometimes growing stronger, sometimes weaker. Massive stellar eruptions burst from its surface. Each eruption sends enormous waves of charged particles racing across the solar system. Earth's magnetic field struggles to shield the planet. Power grids fail more often. Satellites fall silent. GPS systems become unreliable. Global communications repeatedly collapse. Modern civilization, built upon technology, begins falling apart. People once feared asteroids, black holes, gamma-ray bursts. Instead, humanity is being defeated by something far more unexpected. A second sun, one that looked beautiful from a distance, but slowly transformed Earth into a world that no longer felt like home. And if Jupiter continues growing brighter, the worst is still ahead, because eventually, the oceans themselves may begin to disappear. "20 years have passed. Earth is still alive, but barely. Jupiter burns brighter than ever. It now dominates the sky almost as much as the sun itself. There are no truly dark nights anymore. The stars that inspired countless civilizations have almost disappeared beneath the glow of two suns. At first, humanity believed it could adapt. Engineers designed stronger buildings. Scientists developed heat-resistant crops. Cities built massive cooling systems. For a while, it seemed enough, but nature had already crossed a point of no return. The oceans, once the cradle of life, are changing forever. Surface temperatures continue rising. More water evaporates into the atmosphere. Rainfall becomes increasingly unpredictable. Some regions experience years without meaningful rain. Others are devastated by endless floods. The global water cycle has become unstable. Freshwater shortages spread across every continent. Countries begin fighting over rivers, reservoirs, and underground aquifers. Water, not oil, becomes the world's most valuable resource. Meanwhile, the oceans lose something even more important: oxygen. Warmer water holds less dissolved oxygen. Vast dead zones begin spreading across the seas. Fish suffocate. Marine ecosystems collapse. Entire coastlines become eerily silent. The oceans that once fed billions can no longer sustain life. Then, the forests begin disappearing. The Amazon rainforest, often called the lungs of the earth, can no longer survive the relentless heat. Trees die faster than new ones can grow. Gigantic wildfires burn for months. Smoke circles the globe. The amount of carbon dioxide in the atmosphere rises even faster. The greenhouse effect strengthens. Earth enters a vicious cycle. More heat means fewer forests. Fewer forests mean even more heat. Every year becomes hotter than the last. Animals disappear at an astonishing rate. Polar bears are long gone. Penguins exist only in zoos. Countless birds, mammals, reptiles, and insects become memories preserved in old documentaries. Scientists call it the sixth mass extinction, but unlike the asteroid that ended the age of dinosaurs, this extinction never truly ends. It simply continues. Year after year, human civilization shrinks. Many of the world's largest cities have been abandoned, not because they were destroyed, but because they became impossible to live in. Temperatures regularly exceed 55 degrees Celsius, or 131 degrees Fahrenheit. Stepping outside during the afternoon, without protective equipment, can become fatal. Entire populations migrate toward the poles. Northern Canada, Greenland, Antarctica, these frozen regions, once considered too cold for large civilizations, become humanity's final refuges. Gigantic underground cities are built beneath the ice, powered by nuclear reactors, and protected from the relentless heat above. Children grow up learning about blue oceans, snow-covered mountains, and cool summer evenings, as if they were ancient myths. Many have never seen rain. Many have never experienced true darkness. To them, a world with only one sun sounds impossible. Yet, even these underground cities cannot escape one terrifying reality. Jupiter is still changing. Its fusion reactions continue becoming more powerful. Astronomers calculate that if its brightness increases just a little more, Earth's climate system will collapse completely. The remaining ice will disappear. The oceans will retreat. Large parts of the planet will become barren deserts. Humanity faces a choice it has never faced before: stay, and slowly watch Earth become uninhabitable, or leave. For the first time in history, the survival of our species may depend on finding another world. And that raises one final question: could Jupiter really become a star? Or is this entire nightmare impossible? So, could this incredible scenario ever become reality? Could Jupiter, the giant planet we see shining in our night sky, actually ignite and become a second sun? The short answer is no, at least, not naturally. Despite its enormous size, Jupiter simply isn't massive enough. In fact, if you combined every single planet in our solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, it still wouldn't be enough. Jupiter would need roughly 80 times its current mass before the pressure inside its core became high enough to sustain hydrogen fusion. That amount of matter simply doesn't exist anywhere nearby. Our solar system doesn't have enough material to create another true star. But here's where things become fascinating. Jupiter isn't completely cold. Even today, it generates more heat than it receives from the sun. Deep inside the planet, immense pressure slowly compresses hydrogen gas. As Jupiter contracts, gravity converts that compression into heat. This process has continued for billions of years. That's why Jupiter radiates energy into space even though it's only a planet. If it had formed just a little differently, or accumulated dozens of times more mass during the birth of the solar system, it wouldn't have become a planet at all. It would have been a red dwarf star, and Earth would have formed inside a binary star system. Two suns, lighting our skies from the very beginning. Astronomers have discovered that such systems are actually common throughout the galaxy. Millions of planets orbit two stars. Some experience double sunsets, others have no true night at all. So while Jupiter can never naturally become a star, the universe is already filled with worlds where this is completely normal. Still, even though our scenario is fictional, it teaches us something extraordinary. The solar system exists in an almost perfect balance. Move one planet slightly, increase one planet's mass, or change the brightness of one star, and everything changes. Gravity shifts, climate changes, orbits become unstable, life itself becomes uncertain. Earth's existence depends on an astonishing series of cosmic coincidences. We're exactly the right distance from the Sun. Our star is remarkably stable. Jupiter, ironically, already protects us. Its immense gravity deflects or captures many comets and asteroids that might otherwise threaten Earth. Instead of becoming our greatest enemy, Jupiter has been one of our greatest guardians. Without it, life on Earth may never have survived long enough for humanity to exist. Sometimes, the most terrifying, what-if scenarios remind us how incredibly fortunate we already are. The universe is filled with violent stars, exploding supernovas, black holes, gamma-ray bursts, and planets far stranger than anything we've imagined. Yet somehow, against impossible odds, Earth became a place where life could flourish. And perhaps, that's the greatest cosmic miracle of all. If you enjoyed this journey through one of the universe's most fascinating possibilities, be sure to subscribe to What If Beyond, because the next question may be even more unbelievable. Until next time, keep asking, what if?